right. Hi, everyone. I'm Flavian. I work with Sandrine, which you may have seen at the keynote earlier. And it's with great pleasure that I introduce Fabrice's talk today. So I've known Fabrice for many years. And one thing I've learned is that spending time with Fabrice is it's like giving your general knowledge a full upgrade. It'll open your mind to topics about politics, ecology, finance, and even the art of living. Fabrice has channeled his creative energy into his book, The Lean Tech Manifesto, which I have here. It's a great book, and you should read it for sure. It explores how to apply lean thinking and lean principles in tech through the lens of the TPS, so the Thinking People System, better known as the Toyota Production System. The book draws on fascinating stories around the globe, as well as Fabrice's own pioneering experience with lean while building the Theodo software agency, which enabled Theodo to scale from just Fabrice and Benoit, who's the CEO and the book co-author, to a team of 700 people internationally. Their journey was guided by the lean senses like Michael Ballet, Regis Medina, Sandrine Olivencia. And I had the privilege of working at Theodo myself, and I can tell you that they truly walk the talk. Theodo is very unique, and it's an extraordinary company. And I had a great time there. It changed my career path forever towards lean. So I'm very grateful for that. And during today's session, I'll be assisting with Q&A. So feel free to share your questions as the talk progresses. I will address them as we go or save them for the end of the session. So without further ado, let's give a warm round of applause for Fabrice.
Oh, thank you. I'm not sure we can hear the applause. Yeah, thank you very much for joining the session. So I wanted to talk today and address a misconception which I've heard a lot in the Agile community, but and I would say with a lot of people that lean is something about manufacturing. It's about repetitive processes, and it's not at all about creativity and innovation. And I wanted to show how lean thinking, and in particular lean tech, is actually an amazing tool for creative innovation. And let me start by what is often associated with creativity and innovation. It's what started in 2000s when all these success stories in tech emerged with all their new ways of working that seem to be incredibly creative. And indeed, not only were they cool, they were really like helping these companies disrupt their industry. All these companies like Google, Apple, Amazon, Uber, Spotify, etc., Netflix. And what they were doing, this way of working that seemed to be working better, came to be known as Agile. And just to give you a bit like the backstory of Agile, there were a few pioneers really thinking about how can we, in the particular context of software engineering, how can we find, codify better ways of working that really help us build better software, more innovative software. And they realized they had a lot of ideas in common. And so they came together to try to identify the principles they shared. They actually met in a resort in Utah, and they came up with 4 guiding principles that they all agreed on. And they called these 4 principles the Agile Manifesto, and that's how the word agile became really the word capturing this idea of creativity and innovation that all the startups were actually adopting. This agile vision of innovation and autonomy didn't just convince startup, it became really like the thing that every organization in the world wants to adopt. In a recent survey by Deloitte, 94% of business leaders said that agility and collaboration was critical to their organization's success. But most failed to adopt it. Only 6% said that they were actually highly agile. And in the same survey. And I think that's a really, really important issue that we need to try to address. And at Theodo, we clearly had a similar experience. As when we start understanding agility deeply, it allows us to innovate super fast in the right contexts. And the right context could be large organizations. Two of our early agile projects were with Safran and BNP, which are two large organizations. But we were able to build using Scrum methodology and sprint programming. We were able to build new products that we released in a matter of weeks, 6 and 8 weeks, that we had iterated with the end user, and so we ended up with adoption of that product beating expectations. Whereas in a different context, where there were a lot more regulatory complexity, architectural complexity, IT system dependencies, and things like that, well, agility was not enough to build innovation fast, and so a similar app with all that complexity added to it could actually take 18 months to be deployed in production. So when we thought about that, we were like, okay, agile is great to be innovative in certain contexts, but how can we? What is the solution to continue innovating at scale? We realized that the Agile Manifesto had never been designed for innovation at scale. It's been designed to really capture what makes a small team incredibly innovative, but not how to make a large organization innovative. And just to give you an example, because I don't want to dive too much into it, and if you want to know more, I describe all this in the book. But just to give you an example of, that exemplifies this idea that the Agile Manifesto is not meant for large organization. If you take one of the key principles, the first one, individuals and interactions over processes and tools. So this idea that if you want the team to be creative, you have to stop just thinking in terms of processes, and you actually have to let the collaboration work mainly through ad hoc interactions. It makes incredible sense in a team, and it works. But when the number of individuals grows, the problem is the number of possible connections grows to the square of that. So and so it quickly diverges to the point that a team of 12 people has 66 potential interactions, and an organization like Amazon with 1 million employees has like billions and billions of possible interactions. So this principle just doesn't tell you what to do to avoid being stuck in processes and tools at large scale. So we wondered, how did big tech companies stay innovative at scale? And when we started studying this, we found really two things, two shared secrets among these organizations. And the first one was lean thinking. And in case some people in this webinar don't know about these two stories, I'm very excited to share them with you. The first is that while looking for the shared principles, we discovered this amazing backstory of Steve Jobs, who, after being fired from Apple, so late 80s, created a new company called Next. And at that company, he got very fascinated by Japanese quality management systems, which were quite trendy at the time, and decided to go straight to the source, so get coached by Dr. Jurin on them. And of course, Dr. Jurin, for those who don't know him, was one of the few professors, American professors, that were sent to Japan post-World War to help on reconstruction, and who brought their very innovative theories on quality management, but also stayed in Japan. So they influenced Japanese leaders, but then they also got influenced by Japanese organizations. And so Dr. Jurin was clearly one of the pioneers of lean thinking before it was even called lean. And he coached Steve Jobs on that. And in the video you can find on YouTube, you can see how much Steve Jobs really understood some of the lean thinking principles quite deeply. Another iconic tech entrepreneur is Jeff Bezos. And it's documented that actually quite early on in the history of Amazon, like late 90s, he studied the Toyota way and applied really some of these ideas, and then went even further when he hired lean expert Mark Cornetto, who was trained on lean thinking by Nakao-san and Shingijutsu, and brought Nakao-san to Amazon, and brought Jeff on the Gemba to do Kaizens, and to deploy lean thinking really globally at Amazon. That's one thing we discovered, really like breaking this idea that lean thinking was just about standardizing and manufacturing processes. The other thing we found, and this is also to at Lean Global Connection, to talk not just about Lean, we found that tech had been a key enabler in these companies, and in particular in making these organizations, in enabling teams to stay more autonomous, even in larger contexts. So two really key examples. One is Linux, where we realized that Linux is this open source project that actually runs all the Android phones, all the top 500 supercomputers in the world, and most web servers in the world. So you're basically using Linux every day without potentially realizing it. And Linux has been built by mostly free contributors. So people doing it on their spare time. And of course, they wouldn't do that if it was a very bureaucratic process, because they're doing it for the fun of it. And so it was key in the success of Linux as it grew to, from one hobby project from a student in Finland to like tens of thousands of contributors, to keep this kind of fun and very voluntary spirit to the project. And one of the things that happened when the project really started to scale and started, of course, hitting scaling issues, is this genius idea of Linux to say, okay, we need to try to find a tool that enables a more networked organization. And that tool that he ended up finding was called BitKeeper. And there's really a before and after adopting this tool. After adopting BitKeeper, the Linux community was able to really distribute some of the merging challenges that they had, and therefore make it much easier to continue scaling without Linus, so the founder of the project, staying a bottleneck. If you've never heard of BitKeeper, it's because at some point the founder of BitKeeper threatened to make the Linux community pay for it. And so Linus, the founder of Linux, took a few weeks off to build a free competitor, and that's how he built Git. And Git is actually now being used by probably 97% of engineers in the world, because it's this amazing tool that allows us as software engineers to distribute our work across multiple teams. There's a very similar story actually at Amazon. When in 2000, Amazon has grown very fast, and they are stuck with the typical issues that you have when, dependencies between the different teams and the difficulty to prioritize transverse projects. They end up with a lot of bureaucracy. And so if you want to make a change to the database, you need to wait months. You need to fill in a form and submit it to the database administration committee, and then wait for them to meet and decide whether your change is good or whether it's not detailed enough, and if you have to fill in the form again, and all these things that you will find in a typical organization. And the genius of Jeff Bezos at the time is to realize that not only this is critical to their success, because it's really the talented people are leaving and they're losing in terms of innovative spirit. And the other thing is, he's realizing that what they need to do is not improve communication between all the teams, but really reduce communication between these teams. And so they start a really intense project of re-architecturing Amazon.com, the website, to a much more modular architecture, which they call a service-oriented architecture, and then really work hard on the quality of the interfaces between these modules, which are called in software engineering APIs, to make sure that once the teams are assigned to a module, the dependencies they have with other modules are so intuitive and so high quality that they don't need to meet with the other teams to access their data and access their services. This, of course, means that the team become autonomous again, as if they were, in a small startup, and allowing that team to be very innovative again. And so, as I mentioned, for me, this is really already a proof that, people who say lean should be only for a repetitive task. I've really misunderstood the power of lean thinking. But I think also one of the reasons is they don't know one of the superpowers of lean thinking in terms of creativity, which is value analysis and value engineering. And for me, like, I think the best example I've found to really understand what value analysis, value engineering means is an example in lean strategy of in a story that was experienced by Freddie Ballet. And the idea is, I tried to tell the story, it was hard for me to illustrate it. But the idea of that story is that when Freddie starts working for Toyota, they send a sensei to come regularly on one of their little cells, building rear view mirrors. And or I think also signaling lights. Let's say it's signaling lights, actually. And over a period of 1 year, they will do continuous improvement and like a succession of very small problem solvings on around that machine and around that team to find productivity gains. And they will end up actually finding 30% of productivity gains on their processes. But there was one other person that was coming at these monthly sessions that nobody knew really who they were, and it turns out that that person was actually the designer of these signaling lights. And by being there and looking at these small problem solvings on the ground, they were able to come up with a new design the following year, and that new design was costing 27% less, because they were able to really see all the constraints on the manufacturing floor, of course, improve a lot of that, a lot of these constraints, but also understand where were the places where you could actually save on material, because they would not be an issue and once in production. So very strong collaboration between design and production, enabled by these little problem solvings on the ground, allowing then the designer to come up with a new design, which of course, and this is quite interesting, brings a much bigger change in terms of P&L, because the cost of production was 10% of the total cost. The cost of material was actually 90% of the total cost. And therefore, the 27% gains on the material were the game-changing productivity gains. And for me, this is a great example of how, if you do continuous improvement at small scale, it ends up inspiring you with like large changes that have that do impact the company potentially much more. And I wanted to share with you 3 examples of such innovation inspired by VA and VE at Theodore and deployed very fast then with technology. So the first one is quite internal. This is our security policy. So we've adopted what we call a Dantotsu culture, so of systematic problem solving in security. So what we do is we have regular audits, and of course teams also come up with issues on their own. And every time we see something that could be a security related issue, we will record it and then have a problem solving around it. And what is very interesting is you end up solving every singular issue. But of course, what it does is that it has inspired over the years our Chief Information Security Officer to come up with some key innovations. And one of them, for example, has been to build a security cockpit. And because he realized that instead of having to problem solve everything, he could do preventive maintenance, and so that was a big change, of course, that solved a lot of issues at once. And this is also where you see the power of tech, because this cockpit, they were able to build it as a small team in hours or days instead of months, because of course they had autonomous access to all the data of all our toolings through APIs. Because as a quite tech native company, we only adopt IT systems that provide their data through APIs. Another such innovation, which I find really nice, is they realized that a few of these issues were linked to, let's say, a too generous sharing policy. So what they did is they realized that instead of just forbidding sharing documents with everyone else in the world. They just replaced the button that says sharing with anyone by a link to the standard that explain why you should, really use that option as little as possible, and only after you had been trained with the risks that it could entail. And so that again was instantly deployed because they were able to. We have a small extension that is able to customize all our toolings, and as soon as you deploy a change in that extension, well, all our tooling, the tooling of all our 700 people is impacted instantly. So another example on internal products, we've been doing a lot of migrations, so code modernization using GenAI, and we've always tried in these efforts to do systematic problem solving. And so typically, to illustrate what it means, for example, this is a mobile application in what we call native technologies. And today, there's a much better technology that should be used for such mobile applications, which is React Native. And so the idea is, can we take the legacy app, put it in GenAI, and then get a new app? And the answer is, well, it does. First answer is it works. But second answer is it doesn't work perfectly. And so having this culture of systematic problem solving allowed us to realize that, okay, you could try for every special case to improve a bit the way we were using GenAI, but we actually came up with a much more, at some point, with a much better solution, which is to create a product for the developers that will really empower them in this case, so in their development environment, to customize the context that we were giving GenAI to migrate the code. That means that instead of trying to solve the problem individually, we decided that we would actually create a better tool, better tooling for the devs, allowing them to actually tailor the GenAI prompts that we had built to their needs every time. And so the result is, using that tool, they were able to generate that kind of screens. So something where you don't see the difference, but it's actually in a much more modern technology. And my final example of impactful innovative change that was brought by systematic problem solving. So we found that on projects, we often had issues around testing, JavaScript testing. And that was, this comes from looking at issues and analyzing them quite deeply, could improve on them. And we went, and at some point, seeing these issues coming again and again and again made us want to really go much deeper, more deeper than we had ever gone before. And what we realized is that the issue was not with us, it was in the testing library called Jest, that is actually used by tens of millions of projects around the world. At least, they say they're being used by 11 million public projects. So you can imagine the number of projects in total when you add all the hidden projects across organizations in the world. And what we realized is there was a very deep issue inside the library allowing parallel execution of the testing. And we decided to go and fix it. And of course, the power of technology is that once that fix was actually merged into the code, it was deployed globally instantly. So, and potentially solving headaches on tens of millions of projects, and also saving a lot of energy, because the impact of that bug was that it was forcing people to run the test twice, and therefore using twice the time of computing needed. So my take-home message as a conclusion to this is that, yes, lean thinking is an amazing weapon of creativity. Lean gives us, in particular, value analysis and value engineering. at scale. So you can get the same magic that you have in an agile team, but you can really help make it more systematic across a much larger organization. And I think the people who still think that lean is not creative should know and really inquire about VA and VE. I also think that tech has been for us incredibly impactful in doing two things: enabling more autonomous teams by enabling a network of teams organization, and also in deploying the innovations much faster. Anyway, if you want to learn more about lean tech, we've captured all our learnings of combining lean and tech in our book, the Lean Tech Manifesto. And you can also follow me on LinkedIn, where I try to post about these things quite regularly. Thank you very much.
Fantastic. Thank you, Fabrice. You got quite a few applause, but no question yet. Does anyone want to ask a question to Fabrice? If not, I'll maybe have
Let's
one.
stop sharing, maybe. I don't see myself. I don't know if I'm actually visible.
You are visible.
Okay, nice.
All right. No question. We have a shy public today. It was a great session. Thank you so much from Lorena.
Thank you.
Thank you,
Great question.
If there's no question, I'll ask a question then. There's one question from someone we don't know their name. How to implement lean development for software in pharma industry with computerized system validation requirements. So I guess in a very bureaucratic world, how do you do that?
Well, it's the example of this project that took us 18 months is a good example. We really spent these 18 months doing problem solving on a weekly basis on why it was taking 18 months. And the result is that the following project took 4 months, and the following one 3 and 2, and then all the following projects took 2 months. So I think if you have patience, so you need 3 ingredients. You need patience, like it's not going to work overnight. You need leaders to be open to creative thinking, and typically in this example, so banking environment, security environment. The first sessions with the head of with the security leader were really frustrating, because he was just saying no to everything, and we had to escalate quite high to the head of security to say, okay, can we go back to the principles of what you want to achieve as a head of security, instead of just saying no all the time. And as soon as the head of security said yes, we were able to move forward much faster. So I would say you do need the right leaders in the room to be able to problem solve creatively, take into account all the regulatory requirements, but also slowly come up with solutions that actually allow you to have both worlds: regulatory compliance and very fast innovation.
So, and the problem solving PDCA part of it is really important as well, right? It's from the people doing the work, they will solve some of the problems themselves, but then they can demonstrate that some of them they are.
But I think in the regulatory requirement, if you don't have, you need involvement of regulatory leaders to be able to at some point unlock issues. Or of course you will get like a lot of frustrations on the ground, because you can problem solve as much as you want, but if the framework in which you're problem solving is like really rigid and stupid, then it's it doesn't help. We've got another question, but I don't know what COBIT is.
Do you have any thoughts on SAFe? That would be the second question. This one you can
yeah, I mean, I've had a very popular post on LinkedIn around that. I think SAFe is a step forward for organizations that have very slow cycles. Is it a step forward in the right direction? It depends. I think it's better to move than not move, but it's even better to move in the right direction. And what one of our experiences of SAFe is it doesn't focus enough on value for the customer. So it creates a lot of distance between value and the engineers. So you really lose this magic of innovation that is often linked with agile, which is engineers coming up with innovative solutions. and therefore, you know, if your situation is worse than safe, then maybe safe is a good first step. If you've reached the stage of safe, then you should definitely try to move forward to a better environment with more autonomous teams, where teams are more autonomous on the value and therefore are able to innovate and problem solve straight on the value issues.
Lorena asks, did you have any problems with getting everyone involved into the Brain mindset?
I mean, as a company, we've started to adopt such a culture quite early on in our journey. So of course we've had that that advantage, and we also have historically hired people that were um, quite young, so didn't have other ways of thinking before joining us. But since then we've grown and we've hired a lot of senior people, and yes, I think there is the necessity to onboard them on this, necessity to train them on problem solving, and and coach them and help them on the problem solving, because at first it's very difficult for them to um, to adopt this kind of problem solving mentality. But it's also not that hard with and most people, once they start mastering the gesture, love it, and become advocates, and probably one of the reasons why then when people leave the company, they keep that part of the culture very strongly, and take it and deploy it across the world, which is of course something I'm very proud of.
Maybe we have time for one last question. I see that because we're a bit over time, but Madhu is asking, how do you navigate or move past debates about framework purity, such as agile versus lean?
I think first, there's something positive about the debates, which is to try to understand what each community has can bring that is very positive, and that the other community might have disregarded for various reasons. Um, and one thing I think that the Lean Tech Manifesto has done quite well is really bridge, for example, the Agile community and the Lean community, showing them how Lean. I think the book does a great job at showing how Lean extends Agile on a lot of topics, but agility, or at least the Agile community, who are usually very tech savvy, also brings a lot of tech innovation to what an organization can do at scale. And I think that's for me, the debates are useful if they're constructive, and if people kind of debate to understand what everyone can bring to the party that is useful to the success of the company. But of course, the best way to pass the debates is focus on value for the customer, and problem solve how to create more value for the customer, and then you take the best tool for that.
All right. Thank you, Fabrice. And thank you for your great questions in the public. And we'll end the session there. Bye.
Thank you, everyone.